Hello everyone, my name is Andrew. Today we continue learning programming and today we'll talk about DDoS attacks and how to prevent them. So let's start. Once again, today we'll discuss DDoS and DOS attacks as well, but I think many of you don't know that DOS is somehow related to DDoS, but I'll explain all of that and we're going to talk about how to prevent them, what is interesting about them, and what are the problems of DDoS. So let's start. First of all, let's answer the question, what is DDoS attack? So imagine you have an app. Any application that is open to the users. So it can be a web app in our example, because web applications are the most known for DDoS attacks, because basically whenever you want to DDoS something, you need an internet connection to do that. You basically need any connection to do that, because DDoS attack can be represented in other layers, not only in the internet layer, but I'll explain all of that. So what is DDoS? Imagine that our application serves some requests for some users. So our application just gets the requests of the users and returns the responses to those users. If you don't know about HTTP, and HTTP is the most known protocol or the most used protocol nowadays, well, aside from TCP, UDP and all that stuff, HTTP protocol, it's hypertext transfer protocol, which is used in the web, and lots of DDoS attacks happen with HTTP protocol. So what we need to do in HTTP is open a connection, then process that request. So open a connection, send some information, process the request, and then we need to return the response. And basically almost any connection, almost any protocol does the same. Some protocols can open a connection and leave it hanging, so we can send data back and forth from our server to our user and from our user to our server. However, HTTP does not do that, and it will be very important in one of the DDoS cases, but for now, all we need to understand is that we open a connection and we send some information using that connection, and we can receive some information back. But imagine that our server is a machine, and each machine has its own capabilities. And imagine that our server can only serve 500 requests, so error per second, requests per second. What will happen? If a hacker, so let me call it H, it's another machine, will send not 500 requests per second, but it will send 1000 requests per second. So basically, that is DDoS. Whenever our machine just can't, or our machines, our servers, our software, our hardware, any of that, well, basically our hardware, software is a little bit different, can't process all of the requests, or just does not have enough RAM, enough processing power in order to serve all of those 1000 requests. Because basically, once again, that is our maximum. So 500 requests per second is a maximum. And if I send 1000 requests per second, then basically we exceed that limit twice. And because of that, our application basically does not work. And what is the problem with that? Because if we use that DOS attack, that is called DOS attack, not DDoS. That is not DDoS, that is DOS attack. And I'll explain the difference, but for now it's a DOS attack. The problem with DOS attack is that we don't get any information from our servers, we don't get any keys, any passwords, we don't break into our system, we can't we basically just send requests. We basically just send the data, we basically flood the whole network of our application. And the main problem is not gonna be with the security of the application itself. It's a part of security, but like the security, the passwords, all that stuff will be fine. What won't be fine is the users that are gonna use our app. So imagine the user wants to use our app. We are already sending 1000 requests to that application. My 1001 request is not going to be served, because basically our application does not have enough capabilities. So what we can say about that application is it's basically unreachable, because we exceed the maximum amount of requests for that application. It can be a maximum amount of requests, so it's just like an example. It can be anything: processing power, RAM, CPU, any limited resource, so basically anything. And yeah, so that is called DOS attack. So what is DDoS? What is DOS? What are the differences between those two? Well, basically DOS is a very specific type of attack. Well, basically DOS was the first attack. Is when you basically send all of your food from one computer. So all of the requests come from one IP address, come from one computer. It's called DOS. And the full name is denial, I think, of service, like that. Denial of service attack. That is the name of it. And before I continue with the video, I want to say that don't ever try to execute that attack on anything, because that is illegal. That is still an attack. And my last video was taken down because of the, I don't know why, because somehow I violated the laws of YouTube. But don't do it ever, because denial of service attack is still an attack, and it's still punishable by law. So denial of service. But what is DDoS? Because DOS, denial of service, and DDoS is basically distributed denial of service attack. And the difference is that instead of sending all the information from one computer, we send it from different computers. And what is the problem with DDoS attack? Well, let's think about that. If I, as a programmer, know, or as an administrator, or as someone who controls the app, if I know that there is too much traffic coming from that one IP address, that one specific IP address, what I can do is just ban that IP address. And that's it. It's basically what I need to do in order to prevent DOS attacks. Sometimes it's different, but we're talking about just simple DOS attacks where you just send lots of traffic. I just need to ban that user, and my application will work fine. However, if we're talking about distributed systems, it's gonna be very, very hard to find the normal clients and the botnets. So that is called botnet, where when a hacker has tons of computers in its botnet. So yeah, botnet. And we can't just simply ban the whole net, because we don't know who is the real user or who is the hacker. So what we can do is ban everybody, but once again, that will ban the normal users. And what we need to do in that case is analyze the traffic and ban only the bots of our hacker, of our attacker. And that is much more difficult. So yeah, that's kind of what it is. So DDoS attack is when you execute a DOS attack from different computers, from distributed systems. And DOS attack is when you flood your network, when you flood when you exceed the capabilities of your server, and because of that, your server is unreachable, and basically it does not work, and the business who was or the program that was attacked loses money. So that is the whole idea of DOS and DDoS attacks. So the first question can be removed. The second one is, what are the problems with DDoS? So what are the actual problems with that? Whenever we talk about anything in security, we need to understand that for some problems there is like a fixed, simple solution. For example, if we're talking about very simple solution for something in security, don't expose your passwords. Very simple, but basically, yeah, there are different hashing algorithms and all that stuff. But for some problems, there are fixed solutions. For example, XSS. So XSS attack is another type of attacks. I talked about it before. And what we need to do is basically strip. So strip all tags, or remove tags from all of the requests from our users. If you are curious about that XSS attack, then just watch that video. But basically what I'm trying to say is that for XSS attack and for many other vulnerabilities, there are fixed and simple solutions. But there is a problem with DDoS. Why is that? Because basically DDoS can only be delayed, but not fixed forever. Why is that? Imagine that is our graph. So that is our graph. Yeah, very simple graph. I'm not gonna name the axis, and we have that straight, I hope. All right, we have that. Okay, it's not straight, but we have that line, and that line describes our requests per second. So imagine that we can work with 1000 requests per second. Our application can at maximum work with 1000 requests per second. And we also have our current requests. So that is going to be time, that is going to be requests. And imagine that so our requests, everything works fine, but then at one point of time, our hacker wants to DDoS our application. And what he does is basically he just exceeds the maximum requests per second of our application, and our application breaks. But what is the problem? The problem is that in order to exceed that request per second, so we imagine that that person exceeded it by 150 requests per second, or 1,500 requests per second. And what is the problem with that? In order to increase the amount of requests per second, so in order to DDoS our application, that person needs to spend some amount of money. And the more requests he or she executes on our application, the more money he or she needs to spend. That is the basics of DDoS. So that is the simplicity and the problems with DDoS, because basically DDoS is very, very simple to execute. Of course, you should never do that because that's once again illegal, but all we need to do is just have tons of computers and just send well, it can be a garbage information, it can be anything, but you can just send valid requests, but a lot of valid requests to the application that you're gonna attack. Once again, that is illegal, never do that, but that's all you need to do in order to DDoS your application. You don't need to look for any vulnerabilities and all that stuff. But what is the problem is that in order to execute a DDoS attack, a hacker will need tons of money. Probably tons of money. It depends on the application, because basically if we can only serve one request per second, then all our hacker needs to do is have two machines and send 2 requests per second. But if we're gonna try to DDoS some real businesses, then it's gonna be really, really hard, because we will need tons of money. And how we, as a programmers, as IT people, can prevent that DDoS attack from happening? The only thing that we can do is increase our maximum requests per second. And once again, it can be requests per second, it can be CPU, RAM, whatever. We need to increase the capabilities of our applications. And there are 2 ways of how we can do that. First of all, we can improve the hardware. So hardware can be improved, but there is an obvious problem, is that when you improve hardware, you need something called Ddos. And not every business has, and we don't basically need to improve hardware if we don't have, if our application can work fine without them. Why is that? Because if you are trying to defeat DDoS that will happen in the future by using the expensive hardware, and basically there are 2 ways of how you can spend your money, or how you're doing it wrong. First of all, you're spending your money, and maybe you're not going to need that much of a processing power in your servers. And second of all, DDoS can never happen. So you don't need to think of DDoS as, oh, I'll just improve my hardware. Of course it will work, but it's not the best way to do it. What is better? Well, sometimes it's a necessity, but it's not the best way to do it from my point of view. What is the best way of improving our DDoS defenses is to just improve that bar. So improve our current capabilities. So like that. And imagine that we are gonna have a bar up here. So 2000 requests per second. What can happen? There are 2 things that can happen. Either our hacker will spend a lot more money, or he will not have enough money to DDoS our application, because basically we are up here and he is up here. So money is finite, and because of that we can basically improve that request per second, or once again anything. So processing power, improve our processing power, improve our application, and the hacker will have no idea of how to DDoS our application, because basically he will not have enough money. And that is the basics of how to defend against DDoS, or that is the basics of the problems of DDoS. So what are the problems with DDoS? You don't have one fixed solution. You always need to remember that no matter what, someone will DDoS you. So imagine that right now Google wants to for some reason Google wants to DDoS your site. Google have a lot of money, and despite it being a public company, it can DDoS you, and anybody can have 3,000 requests per second. Anybody can have 5 million requests per second. Anybody can DDoS your application. But what you need to do in order to prevent that is you need to set that request per second bar as high as possible. So if your application can work with more requests, your attackers will need to spend much more money. And that is the basics of DDoS. Okay, how to protect from DDoS? So one thing that we can do as a programmers, and by the way, what I'm talking about here is L7 protection. So in networks we have 7 layers of OSI model. Yeah, OSI model. We call it OC, but OSI, the same thing. And basically L7 means that we are working on the level of our application. There are different levels of DDoS. So you have L4, even L2, L3, but those ways are not as interesting as L7, because basically L4, L2, and L3 mean that what you're going to do is just flood your application, because those layers are the physical ones. We can't really work with them as programmers, because that are all of the routers, all of that stuff in our network. If you want me to talk about OSI model, then just write it down in the comments. And of course, it's very, very important to protect from DDoS on all the levels, because if you fail to protect level 2, then your application will not work on level 7. So that is also very important. But today we're talking about level 7 or application layer. Basically, application layer means the app that we are writing as a programmers. And how we can protect from DDoS? So the first thing that we can do is just improve our algorithms. So improve algorithms and improve data structures like that. And also what we can do is improve code. 3 simple things. So not that simple, but you can do that in order to prevent DDoS. Why that? Because imagine that you have that piece of code in your program. So you have list A, 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, and 10. And in order to, what you need to do in that piece of code is find 10. And what you're doing is for I in A, if I equals A, or equals 10 in that case, once again, we are looking for number 10 in that list. What you're going to do is print I and break, something like that. What is the problem with that piece of code? The problem is that big O, just O like that, is N. So what does it mean? If you have never heard about it, I have a video on that, a very old video, but still I have it. And what that basically means is that in the worst case scenario, your algorithm is going to take n steps. So n steps means that we're going to have n equals n mod a. So basically that means that we are going to loop or look through the whole list in order to find 10. That is very, very bad. So it's not that bad because you can have those types of things. But yeah, it's kind of bad. But what you can do is actually use different algorithms, or you can use different data structures. And for data structures part, what you can do is use dictionaries. Well, dictionaries is not that great either for that case. But imagine that you're looking for something in dictionary and 1, hello, then 10, something like ABC. What is the plus of dictionaries is that whenever you work with dictionaries, what you can do is, or whenever you work with dictionaries, what is the big O of your search is, it's basically 1, because dictionaries use hash tables, and because of that, yeah, you can just find anything using O from 1. So you need to execute one step in order to find your value. But again, it may be not that useful in that case, but yeah, it's just an example. And why did I give you that example is because dictionaries, on the other hand, take up more RAM. So dict more RAM and list less RAM. And as I said, DDoS attacks can happen on anything. They can be in order to defend from DDoS attacks, you need to defend anything. So you always need to think about RAM. You always need to think about algorithms. You always need to think about your clean code. And what you need to do actually is profile your applications, profile them on memory, and basically what I'm trying to say is that if one request to your application impacts 70% of your RAM, just imagine, one request equals 70% of your RAM. Then imagine what will happen if I send 100 requests. I can send them from my computer, I can send them from different servers, and yeah, basically your application is screwed because one request is 70%, 100 requests is 70 and 2 zeros at the end, 7,000% of RAM. So that may be very, very bad for your application, and that will be. So whenever you are trying to improve your application, try to move that zero not after the 7 but before it. So like that, and it's a very, very great thing to have a comma here. So one request is 0.7% of your RAM. Maybe that will help you because yeah, that's what it is. So improve your algorithms, improve your data structures, and improve your code. And yeah, that's kind of what it is. Are we doing all right? If you're asking that question, that means that are we doing all right with our application? And what I'm trying to say is that whenever we want to defend against DDoS, I'll add to the previous point, whenever we want to defeat against DDoS, we are not going to just work with one application because nothing is one layered in our modern world. We always have n layer applications. So basically that means that our application consists of multiple layers. And if we're talking about simple web app right now, we have application 1, we have application 2, we have a load balancer. In available applications, we don't have one load balancer because that's very, very bad. We have different load balancers. If we're talking about Python, we have proxy servers. Well, we have them anyways, but we have proxy servers, we have tons of things, we have databases. So as you can see, our application is not just one layer of something. Our application is a very big and complex system, and I think if you work in software development, you already know that. And the problem is that whenever you work with your application, what you need to do is defend not only the application part, but you also need to defend all the other parts of your application. And yeah, that's basically what it is. It's very, very simple, very, 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 very obvious for that matter. And yeah, kind of like that. So whenever you work with application, defend everything, not only the app that you are working on. So if you know that for some reason one of the layers of your application can be very, very vulnerable, then ask the team that is working on that layer, or ask the person, or do it yourself. So defend that layer and it will be just better. And to add to the previous point, how to defend against DOS and DDoS attacks. If you're using cloud providers, then basically you have DDoS protection there. So you need to be very, very careful with that, because some people think that, oh, I'm just going to turn it on and everything work fine. But no, because DDoS protection in clouds is very, very smart, but still it can be very, very stupid sometimes. So what I mean is that in some clouds you have different services that allow you to protect from DDoS attacks. What you're doing in those services is you just buy them, set them up, and then use them, and you are protected. So that are 4 things that you're going to do. And one thing is that those services can help you a lot. But if your application still, if your application has like 70, every request has an impact of 70% of your application, it's very, very bad. You always need to remember that. Great rhyme, but yeah, you still need to improve your algorithms, improve your data structures, and improve your code. Why is that? Because cloud DDoS protection, it's great. It works. But in 2016, we had DDoS attack on GitHub. So GitHub, and it lasted for 10 minutes. It may seem like, oh, only 10 minutes, but imagine the amount of money that GitHub lost during those 10 minutes. Imagine that your server will not work for 5 hours, for 10 hours, and it can not work for like 5 weeks, 10 weeks. Of course, it won't because you fix it, but anything can happen. That is why it's very, very important to improve your algorithms, improve your data structures, and not just rely on the DDoS protection from your cloud. Of course, if you have problems or if you have any doubts, you need to set it up, but don't forget about those things. And don't forget about all the layers that your application uses, because you always need to think about all of the systems that you run as a business. And interesting, DDoS S, I did not know how to DDoS S or just DDoS. I don't know. DDoS attacks. So interesting DDoS attacks. What are those? We only talked about DDoS as a simple send some information and flood your network attack. But there are tons of other attacks that can happen in DDoS. So one of them is called slow loris attack. Or DDoS slow loris attack. What is that? Whenever we work with any application, our users can have a very bad connection. So very, very bad connection. Imagine that I, as a client of that app, so as a client of that app, can only send one letter per second. So all of the requests, I told you that all of the requests, they have body, they have data. So imagine that I can only send 1 byte of data each second, or 1 byte of data each 30 seconds. So my internet connection is very, very bad. And what can happen is actually our hacker can mimic that. So as I said before, whenever we work with HTTP or any network, what we need to do is open the connection and then send all the data and close the connection. And it's very, very important in HTTP protocol, because your HTTP connection can't just hang forever. You have different things for that, but it just can't hang forever. That is not how that works. It can, but it's not advised. And because of that, what our hacker can do? We can send a simple GET request. If you know HTTP, you know what I mean. If you don't know HTTP, it's just an HTTP request. But instead of sending the whole request at once, what we can do is actually, we can, first of all, get G, send it, and then wait for 30 seconds. Our server does not know what to do, because that is a valid HTTP request. Nothing is wrong with that. So G, okay, get afterwards. After that, we wait for 30 seconds. Our connection is still an active one. We get E. I hope I will get it. We get E, and we send it after 30 seconds. Our server thinks, oh, that person just has a very, very bad internet connection, because we are sending the valid information. Get request is 100% valid. It's not just some rubbish. And then we wait for another 30 seconds. So GE, then T, we send it as well. And all those things happen. And basically because of that, what can happen is that our connection can hang forever. Now imagine that we use a distributed attack and we have not one connection, but lots of connections. And imagine that each of those connections waits for 2 hours. We are still sending the valid requests, but none of the users and none of the real clients can really work with our application, because basically those connections hang forever. We can write a slow loris attack and try it on one of my applications, but yeah, if you just want it. Once again, that is illegal and you should never do that. I hope that video will not be taken down by YouTube. So yeah. And that is slow loris. Basically, you're sending very slow, but valid packets. Like that. And like that, with a comma. And that is one of the interesting DDoS attacks, because basically your server does not know if that is a valid request or not. Maybe I just have a bad internet connection. Maybe that's the case. Nobody knows. And you always need to think about that. So DDoS loris attack. If you want to really exclude those attacks from your server, what you can do is actually hang up a connection after like 30 seconds. But that may be very, very bad because some of your clients may have a very bad internet connection. So you always need to think about that, and it depends on your application. And SoundCloud DDoS protection can help you with that, but only some, not always, and not always. So interesting DDoS attacks. Another interesting DDoS attack is actually not a DDoS attack, it's a DOS attack. DOS attack. So as I said, DOS attacks are very, very simple, and almost none of them can be executed in 2021. Why is that? Because me, you, anybody can just simply get the hacker, so our application, our hacker, we just can look to through our request, and we can just ban that hacker. Very, very basic. But, and because of that, they are using distributed DDoS attacks. But what I want to say is that if your hacker has a very interesting regex attack, so DDoS attack, it's another type of DOS attack, DOS attack. As you can see, it's not DDoS, it's DOS attack. He can ruin your whole application. So if you have never worked with regular expressions before, it's like a string that allows you to search for some substrings. So for example, what we have here, start of the string. So as you can see, it's a very specific code or specific cipher for that matter. It says a source, so you can look at those pop-ups and read what it says. So it stores the position at start of the string, so nothing can be before that. Then capturing group 1, we can have A plus and $, stores the position of the end. So what that basically means is that regular expression will match anything that is capturing group. So capturing group is like a group of something. Then we have A, so literally A. So as you can see, it matched here. So match, everything is great. We executed 7 steps, 0.1 milliseconds, 1 match. Very simple. Plus means that you can have 1 or unlimited amount of those characters. So like that. As you can see, it matched 7 steps, still 0.1 milliseconds. And then we captured that group and we put another plus at the end. So that basically means that those capture groups can happen 1 or unlimited times. Very, very simple. But what is the problem with that regular expression? The problem is that whenever we work with regexes, we need to understand that if I put a very wrong, evil regex or regex, I can use a DDoS attack. Why is that? Because that is an algorithm. That is an algorithm. It was executing for 7 steps, 0.1 milliseconds. And what I can do is put A here, and that for some reason I can put something like B here. As you can see, catastrophic backtracking. So what happened? Or we can actually look at that. That is so cool. I love that site, Regex 101. So what we can do here is actually play what happened. So as you can see, what happens at the first step, or can I just do it like that? No, I can't. All right, first step. What happened? No. Well, all right. What happened? We started at the start of our line. We had A plus, so as you can see, we matched the whole string. Then for some reason, as you can see, we're going backwards. As you can see, we're going backwards, but we never stop. Or why is that? Because of that plus, capturing group plus. So that basically means that you use recursion as an algorithm of your regex. That is very, very bad, because once we meet B, we'll never actually meet B because of that A. And what that basically does is we have very, no match here. Okay, I don't know if I can show to you like that. Let me just put it like, not like that, but like that. I think now, no. All right, let me just put it like that then. I just want to show you what is the... No, all right. I'm not sure to you, but basically whenever you look at those steps, what happens to your regex is that you have very big algorithms with lots of steps. So imagine that you need to execute 5 million steps in order to complete that algorithm. What will happen is that you have very large amount of memory allocated for that algorithm, and because of that your whole application will fail. And DDoS attack is very, very interesting because basically you don't need any money to execute that attack. Once again, don't execute it, it's illegal once again, but what you need to do in order to execute a DDoS attack is just basically find that evil regular expression and just exploit it. Don't do it once again. But DDoS attack is very, very important in terms of improving your algorithms, improving your data structures, improving your code, and improving your regexes. Always remember that. So that is it for that video. DDoS attack is very, very simple, but yet very, very powerful. DOS, very, very simple, but powerful as well. If you want me to continue talking about those types of attacks, because it's very, very late here, but yeah, whatever. If you want me to continue talking about those types of attacks, then just write it down in the comments, and yeah, that's kind of it. So just write it down in the comments and I'll continue talking about DDoS. Thank you for watching, have a nice day, and good luck.